Digital design allows engineers to optimize virtual parts not only for in-service performance, including weight, reliability, and appearance, but also manufacturability and ultimately cost. Parts intended for 3D printing offer new design opportunities previously unobtainable by traditional subtractive manufacturing methods and are particularly ideal for virtual optimization. Spatial's CGM Modeler enables 3D printing applications by allowing the fast optimization of parts for service and manufacturability. In particular, with the aid of CGM Modeler, developers can write user-friendly 3D printing applications that quickly lightweight parts by eliminating unnecessary material while maintaining necessary stiffness. With new functionality in the latest release of CGM Modeler, developers can enable the fast and intuitive creation of supports for efficient 3D printing. Consider, for example, the CAD model of a quick-release lever for the wheel of an ordinary commuter bicycle. The lever is solid because weight is not important. The important attributes for this part are cost, ease of use, and robustness. As a result, the lever is designed simply and can be die-cast from solid steel or aluminum blanks and then machined. However, consider a fancy, high-end touring bicycle and an elite professional racing team as a customer. For such a racing team, weight is paramount. Hence, the quick-release lever must be as light as possible, but also functional and certainly robust. What to do? 3D metal printing provides the answer. 3D printing allows the manufacture of lightweight, stiff parts which are impossible to make with traditional manufacturing methods. For a quick-release lever for professional racers, the original lever can be lightweighted by creating a shell structure with an internal honeycomb lattice to eliminate weight while preserving stiffness and ultimately robustness. With the aid of CGM Modeler's various modeling operators, a honeycomb structure is quickly created and trimmed with external surfaces of the original lever. Then the original lever is shelled to a desired thickness and subsequently united with the trimmed honeycomb structure. Now we have a lightweight yet stiff lever, which is custom designed for a professional racing team. After the lever is optimized by lightweighting, it can be oriented on a virtual tray for 3D printing. CGM Modeler enables an application to select an appropriate orientation for the user depending on various user-controlled geometric options to minimize support material. Simple and angled supports with various perforation patterns and attachment methodologies are easily created with the aid of CGM Modeler's new support operators. First, patterns for supports are created with CGM Modeler. In this example, only one pattern is created for all supports. However, numerous different patterns can be created depending on individual supports to aid in heat transfer and attachment after printing. Second, several attachment locations on the bicycle lever are defined with the help of CGM Modeler. Third, CGM Modeler creates a series of straight supports between the lever and a tray beneath the part. These supports have the aforementioned perforation patterns and will hold the lever during printing while conducting heat away to prevent warping. Likewise, CGM Modeler creates angled supports to support the holes. Now the optimized lever is ready for printing with weight saved, stiffness maintained, and adequate supports defined. After printing, the supports can be easily detached and the lever finished. It is then ready for use. It's off to wish the racing team customer success with the new high-performance, light-weighted, quick-release lever made possible by 3D printing and CGM Modeler. Visit our website today to learn more about CGM Modeler and Spatial's solutions for your 3D application development needs.